This is Amanda Parks. She's a design engineer with the Tangible Media Lab at MIT.
Our group works on this vision called Tangible Bits, which is basically looking at how we can seamlessly move between the physical world and the digital world. So using computational power embedded into everyday objects or environments.
Combining her knowledge of design, mechanics, and electronics, Amanda researches and builds innovative products that bridge the gap between the digital and the physical.
How do we kind of create an experience for people that isn't just about the engineering, but it's really thinking about, the people side, the human side of human-computer interaction.
Amanda and her colleagues have developed a 3D modeling system with kinetic memory, the ability to record and play back motion.
One of the things that I started thinking about with Jacobo was this kind of higher concept of what is it like to sculpt with motion, and we immediately, formed the project around making it a kind of teaching tool for kids.
They've also designed a tool for landscape architects, where they can use sand to form their designs and store them on a computer. Some of Amanda's favorite research combines her love of fashion with the desire to discover how to generate power using the natural motion of the human body. She designs and creates wearable electronics, clothing made from fibers that can generate and store energy.
And this is the first prototype of a project called Bodyscape, which will eventually end up being a piece of fabric that's actuated. So it will actually be able to change shape and hold a shape.
Amanda interweaves the plastic with a wire-like substance called nitinol that contracts when activated, just like our muscles.
So there could be, one state where it's here, another state where it's like this.
You could sort of expand the frame so that it could accommodate a larger or smaller child.
When you're trying to understand the dynamics of interactivity, you really need to be out there kind of understanding how people interact with each other, being a social being, being a kind of part of a social world. Hey, Sam and Joe. Food. We've got a California feast here. Fajitas coming. One of the other ways that I hope my work will make a difference is with my very early startup company, Bodega Algae.
Bodega is developing an efficient way to grow algae that can be used as a biofuel, while also incorporating it into landscape design.
Well, it's like a curse to the people who own the golf courses, and they're always putting toxins and chemicals into the water to kill it. But if we change the paradigm and put up signage in the golf course and said, hey, we're growing this as biofuel, we're going to basically power the clubhouse of the golf course from this pond. As a design engineer, I think maybe one of the most interesting parts of it is the versatility of what I get to do. So really understanding that I don't have to be, wed to one particular kind of engineering. I do everything from building up mechanical models on the computer, designing on the computer, designing physical forms, working in our machine shop, cutting the prototyping materials for this, as well as kind of writing some computer code and designing the electronics. I use the laser cutter a lot, which is basically a machine that works kind of like like an inkjet printer, but instead of actually printing something, it cuts with a laser. Another machine which we use a lot is the water jet cutter, which works a lot like the laser cutter, but with this one you can cut very large pieces of metal with the same kind of high resolution, and this allows us to kind of think in a bigger scale. I think the line between when I'm working and when I'm not is sometimes very blurred. I would still be creating and sewing and designing in my free time. That's what I love to do as my hobby. And so the fact that my work happens to overlap with that doesn't really make it seem like work all that much. I grew up on the beach in California, so I surfed, I played volleyball. I'm still very active in a number of sports. I was a rower as an undergrad. And I think that's also a really important part, keeping a kind of healthy mentality about your body and your lifestyle. So when I was in high school, I always loved math and physics and science, and I also always loved art and didn't quite understand how they overlapped until I got to undergrad, but I found this major called product design, which is a part of the mechanical engineering department, and it was there that I kind of understood that I could apply the aesthetics that I cared about, the kind of creativity that I had sort of honed to a technical project. And it really was a kind of a lightning bolt sort of moment for me when I realized that this could be a profession. Something that is really crucial to my process here as a researcher is the help that I get from the undergraduates who are working with me. You'll be working both on the SolidWorks modeling of the structures that contain the kind of electronics and motors and that kind of stuff, as well as kind of engineering some of the simpler kind of how do we translate rotational motion into linear motion. In terms of making a living, yes, you definitely can make a great living. I get to travel a lot. I go to conferences and art festivals and present papers and projects and do work in exhibitions. And this allows me to meet lots of other creative kinds of people, both on the engineering and on the art side, as well as just having a lot of creative freedom inside of what I'm doing is just a kind of a really inspiring way to live. When you actually make something and it does what you think it's going to do and someone interacts with it and you see a kind of enlightenment coming to them through the object, that's an incredible feeling to know that someone's learned something through using, the tool that you've created.